Hi, I'm Elise Corbin. I'm the Education Coordinator at Peter Francisco Soil and Water Conservation District, serving Buckingham and Cumberland counties. Today we're going to talk about soil. And so, what's the difference between dirt and soil? Well, the easy answer is dirt is what gets underneath your fingernails, and soil is that amazing stuff that's underneath your feet, the ground. And so dirt kind of sounds dirty, doesn't it? Kind of has a negative connotation. So when it's on our clothes, underneath our fingernails, wipe our brow with it after we worked in the garden and it's all over us, that's when it's dirt. But let's refer to it as soil when we're talking about that amazing substance as part of our Earth's crust that just provides so much for us. So why is it important to conserve our soil or take good care of it? Let's pretend like this apple is planet Earth. Now I'm going to cut this in 4 pieces. And let's just pretend like I'm cutting it equally, which I'm not really doing, but let's see. Now, I'm going to set aside 3 pieces. And do you know why? Think about planet Earth. How much is green and how much is blue? Right. 3/4 of the Earth is water. So this would represent the dry land and our soil. So let's set these 3 pieces aside, and now we have 1/4 of this apple. I'm going to slice this in half. So when you cut a quarter in half, you get 2 1/8 pieces, right? We're learning a little bit about fractions, huh? So this piece is the areas that are either covered in snow, ice, or all sand, swamps, high rocky mountains, and that leaves just this other little 1/8 piece that's suitable for people to live. This is just unlivable. Okay, now let's take this remaining 1/8 piece. We're going to cut it in 4, which is going to make each piece 1/32. And we'll pretend like they're all even, all right? I'm setting aside 3 of these pieces because these are areas that are too rocky, too wet, too cold, too steep, or the soil's too poor to actually produce food. Or the land already has been used, like it has buildings on it, highways on it, and so it's not available to grow food. That leaves this little 1/32 piece of that whole planet Earth, which we can grow plants and trees that we need. Now, the Earth's crust is really the soil is about 5 feet deep of this piece of soil. And this tiny piece of peeling represents the very skin of the Earth's crust. And it's what all land animals and humans depend on to grow their food, grow trees for shelter. And so do you think it's important to protect our soil? I think it is. All right, let's clean up our apple mess and we'll move on. So I got some secrets buried in the soil, so to speak. Did you know that some of our soil is stardust? You know when stars flame out or they get pulled to the earth because they're caught by gravity? They come to the earth and they become part of our soil. Pretty cool, huh? Lightning, when it hits the earth, strikes the earth, it puts nitrogen in the soil. Now, what do you think plants need to grow? Yep, you bet, nitrogen. Scientists have found about 70,000 different types of soil in the United States. That's just in the United States, we're talking 70,000 different types. Soil reduces flood by storing up to 9,200 tons of water per acre. Did you know that a handful of healthy soil has more living organisms than there are people on planet Earth? The number of bacteria in 1 spoonful of healthy soil ranges from thousands to several billion, with 5,000 to 7,000 different kinds of species of bacteria. They keep the soil balanced by regulating pH and help degrade organic matter. Antibiotics, antidepressants, antifungal, and anti-cancer medicines are made from this soil bacteria. So all bacteria is not bad, is it? It can be very good. Soil filters out pollutants and wastes. Approximately 10% of the Earth's carbon emissions are stored right in our soil. Over 1.1 billion pounds of pesticides are used each year, and that gets in our soil. Much of it ends up in our soil. About 4 pounds of pesticide per person is what we produce in the world. The United States has at least 36,000 hazardous waste sites right there in our soils. Better take better care of them, shouldn't we? Our soil. And about 4,200 years ago, the Chinese used a soil map to determine how much to tax you for your land, because they knew if you had really good soil, you could produce a lot of food and you could make more money off of it. And if you had very poor soil, they wouldn't tax you nearly as much because they know the production wouldn't be as good. And while soil may be seen like it's at the bottom of the food chain because plants and small invertebrates feed off of the soil, and animals feed off the plants. And so while it's maybe at the bottom of the food chain, it is one of the cornerstones of life here on Earth. What is soil made of? You'll be surprised to find this out. Soil is about half air and water. And then the remaining is the other half is broken rock, decaying plants, and decaying animals. And soil comes in layers in the earth. And so this is an ideal soil profile horizon, okay? Now, layer O, the top layer of soil, is made up of living decomposed materials like leaves, plants, and bugs. This layer is very thin, and it's usually pretty dark because organic material, when it dies, is dark. Okay, the A horizon. This layer is what we refer to as topsoil. It's located just below the O horizon, and it's made up of minerals and decomposed organic matter. It also is very dark in color. This layer that many plants' roots grow in. Then we've got the B horizon. It's a layer that we call subsoil, and it's located just below the A horizon. This layer has clay and mineral deposits and less organic materials than the layers above it. The layers also are lighter in color than the layers above it. Then we come down to our C horizon. This is a layer that we call regolith, and it's located just below the B horizon. This layer is made up of slightly unbroken rock and only a little bit of organic materials found here. Plant roots are no longer found in this layer. And then we have our R horizon, and this is the layer that we call bedrock. So, just like human beings, soil comes in different sizes, and we kind of classify humans as large, medium, or small, don't we? Well, I got this chart here. This is a piece of gravel, so in your mind, this is greatly magnified, okay? But in comparison to a little piece of gravel, soil comes in 3 sizes: small, medium, large. The largest would be sand-sized particle. The medium would be silt-sized particles, and the smallest would be clay-sized particles. And on this, you wouldn't even be able to see the clay-sized particles. So you've been to the beach. You know what sand's like. Very gritty. And the particle's still very small, isn't it? Silt, you could compare that to table sugar, which is finer than sand. A much smaller particle. But really, if you think about table sugar, that's a silt-sized particle. Then clay, it's flour. Think about flour, how fine that flour is. As a matter of fact, if you put a spoonful of soil in a jar of water and shake it up, the clay-sized particles may stay suspended forever. Have you ever seen the James River when, after a really good rain? We have a lot of clay here in our area, in Buckingham and Cumberland, and that washes into the river, and that's why the river turns kind of red after a real good rain, because there's so many clay-sized particles suspended in the water. All right. Okay. So this is exaggerated as well, but let's pretend because there's sand, silt, and clay, the pore space, or the space between each piece of sand and each piece of silt and each piece of clay, we're going to do a little demonstration on that. And so I'm going to use this wall. Normally I would have another person next to me, but since I don't have anybody, so let's say that these are sand particles and the wall is where my fingertip is. This little space right here, there's a lot more space, pore space, between sand particles. Silt particles, let's put my elbow over here, and the space between my body and the wall, that would be the space between two particles of silt. Now clay, because it's so fine, there's not much space at all. As a matter of fact, put my shoulder up against this wall and that's pretty much the pore space. So clay can be used. A lot of horse people would line the stall with clay and then put their shavings on top because the particles are so fine and so close together. It makes a really good thing that wouldn't allow water, or in the case of a horse stall, urine, to penetrate it. You'd be able to scoop it up and stay right in the shavings, and you'd be able to clean the stall real well and keep the stall really nice. So that's the space in between it. Now, most soil is a mixture of sand, silt, and clay. And a loam is actually the perfect mixture of sand, silt, and clay. So scientists use a soil textural triangle like this that will tell you that, kind of describes what percent of clay, what percent of silt, and what percent of sand is in the soil. So I told you that a loam is the best type of soil for growing plants, and it is, let's see, we take the clay, and it's about 20% clay. Now let's move up 40% from sand, and 40% from the silt side, and there's your loam right there. The perfect combination of particle sizes for soil for growing plants. Now, soil comes in all different kinds of colors. And so we have a book, Munsell, a guy named Munsell put together a chart that shows the different colors. And it's just really amazing what he did and how he classified them. So we have red, brown, yellow, yellowish red, grayish brown, pale red. They're good descriptors of colors, but they're not exact. So Mr. Munsell kind of made a real exact thing, doing it by hue, a specific color in relation to red, yellow, green, blue, and purple. Value, the lightness and darkness, with 0 being absolute black, and 5 being neutral gray, 10 being absolute white. Chroma, the color intensity beginning at 0 for neutral grays and intensifying to a maximum of 20. So, did you know that carpet manufacturers look at the soil in your area? When they make their carpet, they try to make it match the soil in your area so the soil doesn't show up so much. That was pretty smart, isn't it? So soil, the soil color is almost like going to the paint store at Lowe's or Home Depot. You know how they have so many different shades of paint? We have red desert soils in California, Arizona, and Nevada. Gray desert soils in Idaho, Utah, and Nevada. We have white sands in New Mexico, green sands along the Atlantic coast. The Red River between Oklahoma and Texas carries red sediment downstream. The Yellow River in China carries yellow sediment. Surface soils in the Great Plains and the Corn Belt are dark because of all the organic matter. Color is affected by minerals in the environment. So like the mineral goethite, it gives you a yellow to strong brown color. Hematite gives a red color. So basic gypsum, pale brown, quartz, a light gray color, and that's what gives soil its color. So, as we stated in our brief overview of soil, that a handful of healthy soil has more living organisms than people on planet Earth. The majority of them are bacteria, we said. And again, not all bacteria is bad. We talked about antibiotics, antifungal, anti-cancer, and antidepressant medicines are made from soil bacteria, and they keep the soil balanced by regulating the pH, and they help decompose leaves, twigs, and other organic matter. And so Next, I want you to take a minute to look at the YouTube video that I'll post there. It's called The Living Soil, How Unseen Microbes Affect the Food We Eat. That's it for the introduction. We'll see you later when we do another little part to it, maybe treasures buried in the soil.